Hello everyone. Today let us discuss some of the MCQs which I have selected randomly from our NCERT. Number 1. According to Coulomb's law, which is the correct relation for the following figure? Look at this figure carefully. You can see here very carefully. Here we have one charge Q1 and here we have a charge Q2. I'll just take 2 points A and B here. We have 2 points A and B. Now if you see the direction of the forces, F12 is directed from our left to right and F21 is directed from our right to left. So what they are asking here, what is the relation, which is the relation for the following figure? So if you see, if the arrows are towards each other, there is a force of attraction between them. Now when there is a force of attraction, now we know that what we know, that is F12 bar is equal to minus F21 bar. Now we all know Coulomb's force, F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. Now if Q1 Q2 both are positive, it will be a repulsive force. If both are negative, then also it is a repulsive force. If one is positive and another is negative, then there is a force of attraction. That means one charge, either Q1 or Q2 must be positive or other must be negative. In that case, one positive charge, one negative charge, positive and negative multiplied, then it becomes less than 0. So the correct option is this one. This is the correct option. So how we got it? Now for example, I will tell you minus 8 into 3, you will get minus 24, which is less than 0. Just I am giving you an example. So if you take one positive number and one negative number, multiply them, you will get a negative number. Product is a negative number which is less than 0. Then after that, let's go for the next question. The second question goes like this. If the magnetizing field on a ferromagnetic material is increased, its permeability, number 1, A, option A, decreases, increases, remains unchanged, first decreases and then increases. As the magnetic field increases, now I am giving you the explanation. As the magnetic field increases, the relative permeability increases and it reaches a maximum and then it decreases. Now if you see the related formula, mu, that is mu is equal to B divided by H. Now if you see, B is magnetic field, H is magnetic field strength. Now if you see that what they have given is B, that is permeability, is equal to B by H. Now if you see, mu and H are inversely proportional to each other. Mu and H are inversely proportional to each other. Now if H increases, that is magnetizing field increases, then what happens here? Mu decreases. Mu decreases. So here the correct option here is decreases. This is the answer. Answer is A. Okay. Now let's go for the third one. A rectangular, a square, a circular and an elliptical loop, all in the xy plane, are moving out of a uniform magnetic field with a constant velocity. V bar is equal to V into I cap. V bar is equal to V into I cap. Then what happened? The magnetic field is directed along the negative z axis. The direction of the magnetic field is perpendicular to all of them. Because they are in xy plane, magnetic field is in z axis, along z axis. The induced EMF during the passage of these loops out of the field region will not remain constant for. So they have given the options. Induced EMF, whenever there is a change in the flux, EMF is induced. Flux is related with the magnetic field. Phi is equal to BA cos theta. Now, if B is changing, that is magnetic field is changing, that is flux is changing, then EMF is induced. Now, what the question is, the induced EMF during the passage of these loops means the loops are moving out of a uniform magnetic field. So, in that case, when they are moving out of a uniform magnetic field, then what is the question here? The induced EMF will not remain constant for which loops? Any of the 4 loops, option A, option B, the circular and elliptical loops, option C, the rectangular, circular and elliptical loops, and option D, only the elliptical loop. Now, if you see here, when the loops are being drawn out of the field, the rate at which the number of field lines cutting them, the rate at which the number of field lines cutting through these loops, that is decreases. Now, if you can understand, whenever the loops are taken out of the field, then when the loops are being drawn out of the field, the rate at which the number of field lines cutting through the loops, that is decreases. But for square and rectangular, it's constant, because the square and rectangular shapes, if you see the square and rectangular shapes, they are like this. So whenever they are going out of the magnetic field, okay, so the rate at which like for square and rectangular, that it's constant, but for circular and elliptical, it is not like that, because their shape is like this. It's like this. So in this case, for circular and elliptical ones, those two loops are equal area is not traced out. That is, it is not coming out in equal intervals of time. That means equal areas are not traced out in equal intervals of times. Therefore, the answer for this question is, this is that is circular and elliptical loops. The answer is B. Now, after that, let's go for another one. Fourth one, the radius of the innermost electron orbit of a hydrogen atom is 5.3 into 10 to the power of minus 11 meters. The radius of the n is equal to 3 orbit is. For this we have a formula. So what they have given is the radius of the innermost one they have given. That is this one. What they have given is the radius of the innermost one. Let us say that is R1. Let us take it as R1. That is 5.3 into 10 to the power of minus 11 meters. Then asked what is R3, that is radius of the n is equal to 3 orbit. We have a formula, Rn is equal to n square into R1. So in this case, n is equal to 3. Therefore, R is equal to R3 is equal to, that is n means 3 square into R1. Therefore, we will get R3 is equal to 9 into 5.3 into 10 to the power of minus 11. Then once you multiply, you will get 4.77 into 10 to the power of minus 10 meters. So the correct option is D. That is, this is the one. 4.77 into 10 to the power of minus 11 meters. Okay, and the next question. Calculate the potential at the point P due to charge of 4 into 10 to the power of minus 7 coulombs located 9 centimeters away. And this is a very simple problem. We all know the formula for potential, that is V is equal to 1 by 4 pi epsilon naught Q by R is the formula. Therefore, here 1 by 4 pi epsilon naught we all know, 9 into 10 to the power of 9. Q they have given 4 into 10 to the power of minus 7 and then divided by R. R means 9 centimeters they have given. Convert it into meter, 9 into 10 to the power of minus 2. Then after that, once we simplify it, that is equal to, now you can clearly see from here, you can cancel out 9 and 9, and then you will get 4 into 10 to the power of 9 minus 7. When this 2 goes up, it becomes plus 2. Then it will become 4 into 10 to the power of 9 minus 7, 2, 2 plus 2 is 4. 4 into 10 to the power of 4 volts. Okay. Therefore, the correct answer is 4 into 10 to the power of 4. Here the option is given C. C. Okay. 4 into 10 to the power of 4 volts. Option is given in C. So 4 into 10 to the power of 4. Okay. So now let's go to the next question. What is the average velocity Vd? So actually this is V subscript D. So this is V subscript D. The drift velocity, we have the formula that is equal to minus E and then capital E divided by M into tau. Divided by M into tau. This is the formula. Okay, where small e is the charge of the electron, M is the mass of the electron, capital E is the electric field, and tau is the relaxation time. Okay, so instead of tau I have typed here T because it's a Greek letter. Then after that, then what is the option? Here they have given in these options where we have the correct answer. We have the correct answer in C, that is minus E by M into tau. So that is the answer. Then after that, the next question, the power factor of a series LCR circuit at resonance will be. So what is this power factor? What is the power factor? Power factor, no, we have actually, I'll take the formula for the power. P is equal to I square Z cos phi. Cos phi. Okay, so cos phi is called as the power factor. At resonance, we all know XC is equal to XL. Therefore, at resonance, phi is equal to 0. Therefore, cos phi, which is cos 0, is equal to 1. That means here, what is power factor? Power factor is nothing but cos phi. So, cos phi is nothing but cos 0, which is equal to 1. So, the correct answer is 1. At resonance, I am just giving you some more information. At resonance, P is equal to I square Z. P is equal to I square Z. Here, maximum power is dissipated in the circuit through resistance at resonance. Okay. AC voltage, question number 8. AC voltage is preferred over the DC voltage because they have given the options. Option A, it can be easily and efficiently converted from one voltage to another. I think this is the answer. Let us see the other options also. It is number 2, it is very cheap. No, it cannot be. Number 3, that is option C, it requires less labor in transferring. It's not true. Number D, both B and C. No, it cannot be the answer. The correct answer is nothing but A. That is, it can be easily and efficiently converted from one voltage to another. We have studied about transformers also, no? Transformers we have studied. AC can be step up transformer, step down transformer. Easily and efficiently we convert from one value to the other value. So the correct option is A. Not only that, it is many more advantages are that. And then after that, let's go for the next question, that is question number 9. A monochromatic light is a light in which mono, what is the meaning of mono? Single. Chromatic is related with the color. That means a single color. Let us see what are the options they have given. So the options they have given are number 1, A, single wavelength is present. B, various wavelengths are present. C, red and violet lights are present. D, yellow and red lights are present. So the correct option is a single color. That means it has a single wavelength. So the answer is A. That is, single wavelength is present. And then let's go for the 10th question. A p-type semiconductor can be obtained by adding number 1, that is the first option, arsenic to pure silicon, gallium to, number B, gallium to pure silicon, option C, antimony to pure germanium, D, phosphorus to pure germanium. Now what we know is from theory, we studied that whenever a pentavalent impurity is added to a pure semiconductor, we get n-type semiconductor. Whenever a trivalent impurity is added to a pure semiconductor, we get p-type semiconductor. In n-type semiconductor, we have electrons are more. The electrons are called as the majority carriers. In p-type conductor, holes are more. Holes are called as majority carriers in p-type semiconductor. Therefore, n-type electrons are majority carriers, holes are minority carriers. In p-type, holes are majority carriers and electrons are minority carriers. But what is the question now? A p-type semiconductor can be obtained by adding, that is a trivalent impurity. So what is the trivalent impurity? Okay, we have so many trivalent, this one, we have aluminum, indium, gallium, and so many things are there. Now out of all these things, what they have given, arsenic to pure silicon, no, and then gallium to pure silicon, yes, that is the answer. Gallium to pure silicon, that is a trivalent impurity, therefore that is the right answer. Okay, I have taken only 10 questions here. Okay, we will meet in the next video with some more questions. All the best. God bless you all.